Greetings and welcome to week 10 of CIT225. We are in the home stretch. We have 3, 10, 11, and 12 are your last active labs. 13 and 14 are optional, extra credit if you care to do them. If not, just catch up with everything you're missing. Quizzes, lab assignments, anything you're missing, catch up so you're good. 13 and 14 will not count against you when it comes grading time. It's amazing we're almost through June at this point. All right, so what we're gonna do today is I'm gonna do like last week. There's not a lot of demoing I can do for you because Lab 10 requires you to write 3 rather lengthy and explicit select statements, which you've done before. And you're gonna be inserting those values into the rental items, and the transaction tables. This is preparing you for the merge command that will happen in week 11. Basically, and just to give you a preview of that, the merge command is this really cool command that lets you take data from 2 tables and merge them together into one, match them on a specific column, add entries that don't exist, and update entries that do exist. So if you have 2 member tables and you're putting them together, if the member number exists, it'll just update the information, you tell which one's the valid record, and if the member number is not there, it'll insert it into the table of record. So, okay, so let's go over the lab here. Let me share out the lab here, which is right here. All right. So this is, this is lab 10. All right. No, this is not, okay, it says, this says it has 4, but it actually has 3. So I don't know why it says 4. So you're not missing anything. Okay, so let's look at each of these 3 steps here. Sorry for scrolling around here. Okay. Step 1 for 24 points. The first select statement uses a query that relies on the mapping of the translation of the table introduced above. This step requires you to create a query that takes records from the transaction upload table and inserts them into the rental table. So look at this sample script here. This is what you're supposed to use. Okay, so go down here. It says naturally we'll be able to start with that select list because it refers to columns not in the results set. So begin with this base query just to make sure all your numbers are there. Okay, and that's what you should get. And let me also add, if you don't get 15, the world's not going to come to an end. You can go back and try to figure out why, but what I would do at this point is I would just marshal forward and get everything written. I've said it before, I'll say it again. These classes are very volatile environments for databases, and it's very easy for one little thing to mess them up so you're not getting the exact results. As long as you are getting results, you'll be okay. And just send what you have, even if like instead of getting 15, you get like 12, and that's fine. Just send what you got, and if it's something I can notice I can tell you to fix, then we'll fix it and go from there. Okay. The first step of this lab, you'll complete a from clause providing all necessary join statements. You should write the join statements with the inner join, left join, or right join operation on the unsub clause. Then you should insert rows, the results as rows in the rental table. Okay. So here are the joins you'll need to make. Join the member table to the contact table with an inner join operator on the surrogate key, which is the member ID column from both tables. Join the foregoing results, which is results between the member and contact tables, to the transaction upload table. As shown in the example starting query, you effect that join by matching the account number in the member table with the account number in the transaction upload table, and the first, middle, and last name in the contact table, in the table contact, and the transaction upload table. Please note that the middle name column may contain a null value, which just says using an NVL function. But NVL just basically says it's in Microsoft SQL there's a function called isNull or if null to give it a value, because if you try to compare a null to something, it blows up. So this is saying if it's a null, just make it blank and everything's cool. Which necessitates using an NVL function on both sides of the join because the equals comparison operator only compares not null values. Join the foregoing results to the rental table. So first you're gonna join member and contact, then you're gonna join that to the transaction upload, and you're gonna join that to the rental table with left join. You should max the contact ID in the column in the contact table to the contact ID in the rental table, or with the customer ID in the rental table, and the truncated checkout and truncated return date from the transaction to upload rental tables. So this is a complicated query, and this is what you should return. Okay, and then you're going to insert that into rental. Okay, so here they're giving you this, right? And then you got to figure out the rest of the solution yourself. Member contact. So let's look down this. All these select statements, right? NVL rental ID next to S1, contact ID, checkout return date, blah, blah, blah. From rental ID, contact ID, checkout date is checkout date, return date is return date. Were created by, creation date, updated by. From member, inner join contact C. On member ID equals member ID, inner join transaction upload. On first name equals first name, and middle name equals middle name, and last name equals last name. And then you got to finish up the rest for yourself on that one. So you got the last join in there. Okay. And then this all goes into the rental table. Okay. Note that you use the NVL function in the select statement to make sure that's done. And then you should insert, after the insert, you should have 4,689 rows in the table. As long as your number is close to that, don't worry about it, you're fine. Excuse me 1 second. Okay. Number 2, mapping values through equijoin value comparisons and translating values through equijoin value comparisons on something other than a primary and foreign key. That's what you're doing here. You map joins between the primary and foreign key columns, or between the natural key and copy key copies. So yeah, when you map joins, you always want to do it between some things that are there. The previous one, you were joining on the last name column, which is fine. Sometimes you map values between only part of the natural key, which can occur with the common lookup table. The common lookup table uses common lookup table and common lookup column to identify subordinate queries, unit table sets, and common lookup table and common lookup type columns, and a unique column with subordinate table sets. After inserting the first query into the rental table, which would do number 1, and selecting the correct row for the second query, you should insert those rows in the rental item table. So this is your starting query for query number 2. Okay. The second select statement uses a query that performs the following joins. You do not need to use the distinct operator because the select list returns unique sets. Join the result set from the first query solution. So query number 1. Join the result set from the first query solution of this lab's first step to the common lookup table. You will need to effect the join between the sustainable inside the common lookup table rather than a join to the common lookup table. This type of join behavior is known as a translating join. You can translate the relationship by turning with following path logic. So you're going to join the previous query with common lookup, and you're going to do on when common lookup table equals rental item and common lookup column equals rental item type. And so instead of doing a situation where you're comparing the values in different columns in the tables, you are doing a physically defined value in there. Join the foregoing result set to the rental item table using a left join operator, which resolves you when the rental ID column is found in the rental and rental items table. Okay. So the last you're going to do, you have the query from part 1. you're going to add a join to the common lookup table using these translative query parameters. And then you're going to take that entire result set and you're going to left join it to the rental item table based on the rental ID column that is found in the rental and rental item tables. And this is what you should see. Okay. When you run your insert statement, before you run your insert, get a count of how much is there, and then run your insert statement. Here is your basic insert statement where you need to add on what's down here because it gave you up to the same thing as did last time. Actually, it gave you all of your first query, which is kind of funny. All your first query. So you take that and add the stuff for lab 2 there. And then your count afterwards should be about 11,533. Okay. So again, you're going to take this query, what they have here, and then here you're going to add on the 3 joins that they were talking about here. Okay. Step 3. The third select statement uses a query that relies on a combination mapping. Same thing every time. Okay. So let's look at the instruction details. Join the result set from the first query solution of this lab's first step to the common lookup table. You need to effect the join between the standable items in the common lookup table. So you're going to take this query, the query from lab 1, and bring that down here to 3. You're going to take those results and join to the common lookup table and join it like this, where common lookup table is transaction, common lookup type is transaction type, and common lookup type is checking the table to find it. So what this is saying here, this don't type that in there. It won't work. And I'll know who made it down this far in the video because you're going to type that. Go in the table and find the correct value that's supposed to go there. That's what it's saying. So go into the common lookup table, get these two where common lookup table is transaction, common lookup type is, or common lookup column is transaction type, and find out where the common lookup type is there, and that's what gets inserted, not check mapping. Okay. Join the foregoing results set to a second copy of the common lookup table, and then do this. Okay. So once again, we're joining the same table twice with a different alias. So this should be CL2 here, not CL1. Am I in the right place? Yep. Okay. So join the foregoing set to a second copy of the common lookup 1 table. You need to effect the join between the suitable inside common lookup queries like you did before. So like I said, here it's not CL1, it's going to be CL2. If you do CL1, it's not going to work right. So make sure you make that change. Join the foregoing result set to the transaction table using a left join operator. You will need to join the following keys: transaction account column of the transaction to the payment account number of the transaction upload table, the rental ID of the transaction table to the rental ID of the rental table, the transaction type column of the transaction table to the correct copy of the common lookup ID, which is going to be CL1. So this connects to CL1, not CL2. The transaction column of the transaction table to the transaction date column of the transaction upload table. The payment method type column of the transaction table to the correct common lookup ID, which is going to be the second one. So this one here is CL2. Okay, this is CL2. And the payment account number to the credit card number in the members table. So that is a whole lot of stuff going on. And here is your template. Working with a query, insert the rows in the transaction table, you should add the where clause to the following insert template. So you're going to fix the where clause in this, okay? And you notice there's no from clause here at all. So you got to do the froms and wheres in this one here. because there is no, that's missing there. So you want to get that done. Okay. So, and that is lab 8. So lab 10 rather, lab 10. Lab 10 is, if memory serves, the hardest lab to code because those joins, if you're not careful, can get ahead of you. So make sure that when you're doing this, you keep track of where the joins are. Do exactly what the instructions say. Use the query that's there. So you are going to nail this. So just take your time. That's all you can, just take your time. And just go and do it again. If the counts don't match, don't lose your mind. Submit the code you have. Let me take a look at it. It may just be that your data got pushed in the wrong direction during one of these other labs. This is not a healthy way to run a database by any stretch of the imagination, doing all these weird changes every week. And no one expects that in a real world environment, no one expects the data in a development system to be fluid or even well organized. So, okay, I think that covers lab 10. Please let me know if you have any questions. I will be available by phone this week. Though I am away, I will have my phone with me to respond back to texts and Hangouts. Alrighty. Like I said, you guys are doing great. Keep up the good work. Just take your time. You've got this. Again, weeks 11 and 12, sorry, 12 and 13. Nope, 13 and 14. Weeks 13 and 14 are optional. So do not panic about getting that stuff done. Take that time to make sure you got everything else that's important and required completed, which is the labs as well as the quizzes, because they count. All right, if you need anything, you know, get in touch with me. You guys, thank you, and I'll talk to you soon. Bye-bye.